So for question 15.56, we've got the equilibrium constant for the decomposition of phosphorus, phosphine, boron trichloride, and we're given the equilibrium constant for that reaction. It basically said if a bunch of this is put into a vessel and then heated to 80 degrees and allowed to decompose, what's the equilibrium concentration of phosphine? And to first determine that, we need to come up with what's the equilibrium, what's the expression for this equilibrium. And normally, it's the concentration of products over the concentration of reactants, except if one of the reactants or products is a liquid or a solid. And so we look up here for the decomposition of phosphine boron trichloride. This is a solid, so that wouldn't show up in our equilibrium expression. So therefore it would turn into the concentration of phosphine times the concentration of boron trichloride. And you might be stumped at this point still, given, I don't have any concentrations to work with, but what we do know, right, if we look at the balanced chemical equation for every 1 mole of the phosphine boron trichloride that decomposes, we get 1 mole of phosphine and 1 mole of boron trichloride out of the reaction. So, right, they are generated, the phosphine and the boron trichloride are generated in equal amounts. So because of that, we can basically say that phosphine should be X and boron trichloride is also X. They should equal each other. So because they should be equal to each other, now we can plug in everything we know into the equation. We've got our equilibrium expression, 1.87, our equilibrium constant, 1.87 times 10 to the minus 3 equals our concentration of phosphine, which is X, times our concentration of boron trichloride, which is also X. So 1.87 times 10 to the minus 3 equals X squared. We rearrange that, X equals the square root of 1.87 times 10 to the minus 3, and X equals 4.32 times 10 to the minus 2 molar. And right here, we can answer the question from part A and part B. So part A is asking the phosphine concentration. Well, we just found that because we said that phosphine is equal to X. So the phosphine concentration is equal to 4.32 times 10 to the minus 2 molar. And then part B asks for the boron trichloride concentration. Well, we found that as well because we said that was also equal to X because they're generated in a 1-to-1 fashion. So we know that that concentration as well is 4.32 times 10 to the minus 2 molar. For the last part of this problem, you basically have to look at, what's the volume that they're giving you and what is the molecular weight of some of these to determine, what's the ultimate concentration. But this is how to get started and define part A and part B for this reaction.